to strives to be the best compact boutique institution with a futuristic approach, encouraging student-centric culture, and sharpened focus on developing industry-ready and employable students with all-round development. Also, since our university is a boutique university and our USP is to prepare the students to be industry ready, and with the as well as our mission is to establish an institution with the so as to promote creativity and innovation and to develop unique quality standards for academic excellence and pedagogical innovations. Currently, GSFC University possesses three schools, that is School of Technology, School of Science, and School of Management, with qualified and experienced faculties for the academic experience as well as the industry experience. For today's session also, that is the topic of today's session is the 3D printing, and for today's session we are having the speaker of the day, Mr. Akash Bhavsar. He also possesses a very rich experience in industry as well as in academics. So I would like to just brief all with his this educational qualifications as well as his affiliation and achievements. So Mr. Akash Bhavsar is pursuing his PhD, and he has completed his MS from University of Utah, USA. He has also published his journals of theoretical biology, also few research papers during his masters in the University of Utah. He is associated with the ASHRAE and ASME. ASHRAE stands for American Society of Heating, Refrigeration and Air Conditioning Engineers, and ASME stands for American Society of Mechanical Engineers. He also possesses a rich industry experience in designing chiller system for industrial application, and exceptional evaporation calculation and optimization of evaporation cooling, energy audits, life cycle assistance, and many more. He has also been awarded with the National Science Foundation Research Assistant Award for the Graduate Research, and also awarded ASHRAE Annual Scholarship Award, Utah chapter. So, as I already told you, today's speaker possesses a rich experience in academics as well as the industry. So we are having a very competent speaker among us today. So now I would request Mr. Akash Bhavsar to just take over and begin the session. Akash sir, I would request you to just take over.
Thank you, madam. Appreciate it. Appreciate for a very nice introduction. So, considering a diverse background of audience today, I'll mostly keep my presentation non-technical. We'll go into some technical at the later end, if time permits. Otherwise, I'll broadly discuss about the application and opportunities in 3D printing today. So, let's start the session. And I would like to thank everyone for joining in and spare your time for the session today. So I'll start my presentation. Okay, great. So yes, so we'll start with okay, so 3D printing or additive manufacturing. So people who are familiar with manufacturing may know that there is additive manufacturing and subtractive manufacturing. We may go later on in the definitions, but basically in 3D printing we are adding material and make components rather than removing material and make component or desired any element out of it. So basically how it works, so it takes digital input from computer aided design. Again, in engineering, computer aided designing are very very popular, and nowadays all industries use it. So after making a model in computer, three-dimensional part out of it are manufactured, and that's how 3D printing is done. Right, it's a layer by layer process. We'll go into detail if time permits. So let's go and understand how it works. So it they are basically broadly classified in three steps. First is to create a 3D image of any component or item that you want to produce, right? In computer software, there are CAD softwares available, which are very advanced, and they can create very complex shapes with them. So first thing is to generate the component inside the computer. Then the CAD information is sent to the printer, right? And after that, the printer forms the item by depositioning the material in layers, starting from the bottom layer onto the platform. And in some cases, light and lasers are used to harden the material, right? So from the bottom it starts and goes till the top. There are 3D printers available for different sizes of elements, but broadly this is the process or workflow which you need to follow to make a component out of 3D printing. Now let's go in a history briefly, right? So Charles Hull invented 3D printing, and he had coined a term called stereolithography at that time. At that time, 3D printing word was not popular, but he started. Then in 1992, first 3D printer was built by company named 3D Systems. Then in 1999, first application of 3D printing in the medical field, creating human bladder, right? After that, so these are some of the uh, points or milestones in the 3D printing technology, and how it got advanced at particular stage. And we will also discuss how it will evolve in future. So in 2000, uh, human kidney was created through 3D printing. In 2006, uh, printing of materials got started, right? Then in 2009, prosthetic leg was created, and in 2011 it was started to making jewelries, right? So these are some of the milestones in different industries in utilization of 3D printer. So in past few years, how it has progressed, and in upcoming 7 years, it is projected to grow by 300%. Right. So we have a source which has predicted that it will go in multiple times. The 3D printing industry has good future in pretty much every field which we can think of. Right. Let's go further. So who should learn about 3D printing? So the one who want to help someone to make his dream come true, right? So this includes pretty much everything, right? I mean, you can think about what a person uh, think, or what should be there in someone's dream. So let's think about a family, a new family who is looking for a house. So we can help them by 3D printing a house. I'll share a small video, right, to ensure that we can see the entire process how it uh, comes through. Let me share that. So here you can see how a house is built with a very reasonable amount and sufficient for small family.
So having strong, sturdy walls, having a door that we can close at night, it's something that we take for granted, being able to lock our door and be safe. For many of these families, for years, sometimes even a lifetime, they don't have that opportunity to have a safe shelter. So when they move into a new story community, when they move into a safe home, families' lives are transformed.
So we can see just windows and doors have been installed by human workers. Otherwise, everything else has been made by 3D printer.
Our first product is a 3D printer that can print a house in 24 hours for half the cost. Phase 1 for News Story and for Icon is a proof of concept house, and the good news is we've done it. We printed the first home in the United States that's going to be permitted. And for us, this is just the beginning. The real kind of home run for us is to be able to do what we've done here in Austin, Texas, in the developing world. And we're doing that in what we call Phase 2, which is in El Salvador. We are going to be printing an entire village for people that don't have homes.
So, someone say that I have a house, but he can dream of, if he loves food, he can dream of having nice dinner. So, let's see if we can get a dinner out of 3D printing.
I'm traveling to Eindhoven in Holland. I want to find out more about 3D printed
Let's
food,
fast forward a
recycling
little
some
bit
of the
so that we
1.3
can go to the
billion tons
content.
of food that gets wasted worldwide every year.
So in Europe, the average is about 20% food waste, and then worldwide it's 1/3.
Here, they blend food waste together with seasonings for taste and turn it into a paste, which is then used to print the food.
We can use this technology to create attractive food that really gains value and people are willing to eat it again.
After printing, the food is baked and dried, giving it a second life.
Currently it's not quick enough for like mass production, but that might be a possibility, but we're first focusing on the restaurants.
Restaurants, along with bakeries and caterers, are also a key client of nearby company Byflow. It sells its 3D printer worldwide at a cost of €3,900.
Hi, I'm Patrick.
Hi, how are you?
For now, it's really like beautiful food. It's food that cannot be made by mold or by hand, for example.
But developments are ongoing. Experts predict the 3D food printing market will be worth over $500 million by 2023.
I don't believe it's going to stay these small printers. We're already looking into ways, for example, to make food based on your DNA. We should be able in the future to make food that is good for your body, different than for your neighbor or for your children or for your husband or wife.
And this ganache is for me.
Oh my, it's very good. I feel sort of bad destroying the FT like this.
Beyond beautiful food, 3D printers' ability to improve the appearance and edibility of healthy foods could also enhance the diets of the young, the obese, or the elderly. In Sweden, for example, 3D printed food will be trialed, but I'd like to see some 3D printed food at an actual restaurant. Jasper Kortschmidt is head chef at The Lounge.
We use it up from the butter and the bread to the starters, to the main courses and the desserts. We want it as an additive to our dishes, just the extra, the surprise element in our creations that we make every day.
This cream cheese will take 5 minutes to create.
You can just see all the different layers, so it's like a bit of a maze.
Yeah.
But it's early days for 3D printed food, so it's still very much about embellishments and marketing.
Something you can show your restaurant with, you make an advertisement with, people want to come, want to see, are curious in what it is.
Thank you.
You're welcome.
Right now, it's hard to say whether it will scale up, but it is going to be an industry worth keeping an eye on over the next 5 to 10 years.
It's very good.
So now, if somebody says that I don't like food that much, then probably she is a girl, then she must like jewelries. So let's see if 3D printer can help us to generate some jewelries. Can see some of the beautiful jewelries are made.
Do you want to learn to draw professional and impressive artwork from
Okay, so looks good, right? It can do pretty much most of the things and which needs to be done. So that's great. Now let's back to the session. I hope you got some idea that what are the applications, we'll discuss more. uh, so yes. So some of the examples I'll go through are already in use, right? That what are the other things which 3D printing can capable of? So concept of modeling of uh, any small model of any structure, right? So particularly if you have visited any buildings, right, popular buildings, for example museum or anything, there are small models of them, which kind of prepared by architect beforehand to see and visualize the entire aesthetic of that particular location. So for that, 3D printing is the most popular and most efficient method, and nowadays it is vastly used for the same, right? Let's see next application. So in cars or any mechanical component, 3D printing is getting very fast, right? Here we can see example of Lamborghini, where its model has been 3D printed uh, to build prototype of the car, because in high-end cars, aesthetic of the car from outside is very important, and it is very important for the designer to visualize how it will look. Otherwise, what a car may be very efficient, but if it doesn't look good, it is hard to sell. So beforehand they kind of make a different 3D printed models to see which one looks better and go with the better aesthetic one, to ensure that they can get a car which has appeal from outside aesthetic, right? Next example is of manufacturing tools. So, I mean, there are thousand examples which can be given for manufacturing tools, because nowadays customization is very much required in most of the applications, right? Particularly when machine is designed for some application, and when you are trying to use it at different location or for different application, it requires massive customization, and 3D printing is the most efficient and fast way to do it, right? So quick low volume tooling and custom fixtures can be provided using this technology, right? Particularly when you are providing fixtures. So for non technical people, fixtures are the things which are used to hold your element for some sort of process. When you are processing uh, some uh, some method on particular element, it has to hold well, and to be able to hold that component well, that particular fixture needs to be customized to the size of the element, and it requires a lot of different fixtures, and production of those fixtures can be easily made using this 3D printing technology. It is widely used nowadays and has more prospect to for it. Then end use parts. So end use parts means the parts which are kind of used by customer, right? So those things usually requires good aesthetic, right? When you are giving something to customer, he will first thing he judge the product by its aesthetic only, and you have to ensure that you provide it very nicely, right? So it is capable of durable, stable and repeatable parts in the industry. Kelly manufacturing company, in aviation, it has used 3D printed components, right? Then finishing. So I mean, it's hard to get this kind of surface finish by getting you know surface removing technology, right? So we know that this is additive manufacturing, and there is uh, other manufacturing where we remove material. If we remove material to make a component, it is hard to get good surface finish, and that's why those things needs to be polished right after manufacturing. But here you get very good surface finish, and that's why you can see the aesthetic. The thing you see is the bottom portion is interior of a car, uh, which looks very good, right? So the interior which requires good aesthetic can be manufactured with using 3D printing technology, right? Then these are plus. So all of us know that, we have seen someone who has kind of broken his bone, has plast on his hand, right? And that plast looks very ugly, and because of protecting that bone, uh, it has to be put on the hand. It is very heavy, so the person who is carrying it gets tired by keeping head in particular position, and it is very bulky, so if somebody hits to it, they get uh, some sort of damage on their hand as well. So instead of that, you can, make creative plast which can easily save your bones and looks nice and creative, right? Particularly used in some of the developed nations right now as well. Artificial arms for disabled. So again, for example, in here there is a person uh, who is fitting a artificial arm on the kid's hand. He doesn't have fingers by birth, and by 3D printing, they are providing it. So medical applications are huge, right? Um to provide you more idea about medical uh, application, I'll also share this 3D printer bionic ear, right? That can hear radio frequencies far beyond the range of normal human capacity, right? So these kind of creative biological product are also made by scientists at different universities, right? uh, it has been made by nanoparticles and cells, right? uh, s- so there are efforts being made to make artificial hearts or any artificial uh, organ, right? As we can see over here in Washington DC, they are trying to do it. I'll also try to share you with similar kind of medical application. So here you will see.
Looking at a 3D bioprinted lung mimicking air sac that's able to pump air into airways, mimic blood flow, and was built using living cells. Granted, it's smaller than a penny, but this lung mimicking air sac could bring us one step closer to understanding how we could replicate human organs using patient cells, which could one day help to avoid organ rejection. The team behind this model is trying to replicate the complicated architectural structures of our organs using 3D bioprinting and use the lung as their proof of concept.
It is a very complicated structure, yet it has extremely clear readouts for its function. If we have
So here you can see they are making lung, artificial lung. At the time of lockdown, we are, hearing a lot more news about coronavirus and
you can see to what extent those
pneumonia, which is causing lung to malfunction. So here they are creating a lung
vessel architectures has been one of the
by
biggest
3D printing
challenges in the world of
artificial lung.
organs. That's because our organs are, well, pretty complicated.
And not just lung, they are also making other artificial
which are physically
organs as well.
and biochemically mixed. And they serve crucial purposes by supplying organs with essential nutrients. Take the liver, for example. It has over 500 functions, like producing bile for digestion and maintaining the right amounts of blood sugar within the body. All these functions depend on the intricate network of vessels to get their necessary nutrients. It's this multivascular architecture that makes mimicking and replicating human organs so difficult. So if we could figure it out, the payoff would be huge. Over 100,000 people are waiting for organs in the US, and bioprinting healthy organs could be a way to address this shortage by supplying replacement organs. It could also reduce the incidence of organ rejection, since bioprinted organs would contain the patient's own cells. But working with living cells is not easy. They're extremely fragile outside of the body, and once they've been extracted, they need to be placed into their final structure as quickly as possible to ensure survival. The cells are then encapsulated within a hydrogel, a water-based material which emulates a cell's environment to allow them to survive for longer periods. So how did Jordan and his team print the lung model? They used a technique called stereolithography apparatus for tissue engineering, or SLATE. It's an open source bioprinting technology that uses additive manufacturing to create soft hydrogels layer by layer by using light from a digital projector.
This is a light-based polymerization system. So we have a light-sensitive liquid that when you shine the right color of light at the right intensity of energy, the right number of photons hit that sample, you can convert that liquid into a solid only in that region.
But using light also created some issues, since the light could get into previously solidified layers, thus disrupting the intended pattern. To address this, the team searched to find an element that could block light and that was biocompatible. And the winner was food dye.
These biocompatible food additives that all of us are eating all the time anyway, we already know that they're biocompatible. They're compatible with live cells, and they can be used as potent photoabsorbers to block the light penetrating previous layers, getting us our complex architecture.
The food dyes were able to confine the solidification to a thin layer, creating the desired internal structures. In the end, these tissues proved to be sturdy enough to withstand blood flow and pulsating breathing, the rhythm that mimics the pressures and frequencies of how we breathe. So this model may be tiny, but it's just the beginning for Jordan and his team. They plan to make more complex designs and scale them up. And in the spirit of teamwork and advancing research, they've made their work's source data freely available.
We're using open source to be able to make the 3D printer. We're giving back to the open source community our designs. But I think scientists in general get a little bit nervous about releasing things into the open because they're like, well, why do people really, what are people going to use this for? I don't really know. You actually want to open source your stuff because you don't know what people are going to use it for. And that's really the power behind open source, and it's really the power behind science.
And thanks to collaborative efforts like these, we'll one day be able to
Okay, so we can see a lot of applications in medical, right? Now let's get back to the presentation. Yeah, organs which we have seen already, right? So some toys and animated characters can be made, right? This is for kids who would like to see the characters which they see in the movie, can be 3D printed and can be 3D printed at home actually. If you can draw them, you can make 3D print out of them. So that is one more application, 3D printing. So 3D printing of your own model, right? So I mean, nowadays uh, you can print yourself. If you can draw yourself in computer, you can print yourself, and it's a best gift to give someone, right? Their own model. So those are some of the things for you know gift or some uh, fashion purpose. Then 3D printing of uh, car, right? uh, so reproduction can be made, right? And reproduction of old vintage models can be made by 3D printing, right? uh, then personalized robots. So nowadays we see a lot of robotics right around us, and we would like them to customize for our need, and it can be easily customized by 3D printed components. So again, there is a good application in robotics, right? And you can customize your robot, particularly nowadays when robots or drones are used, right? If they are fragile, there are some 3D printed parts are placed in front of fragile parts, so that when drone drops down or something, they don't damage fragile parts, for example camera or something, right? So 3D printed parts are good protectors because they are very light in the weight, and they can be first object which can save your drone or device. It is also very reasonable in price, so if they get damaged you can easily replace them. Car that builds itself. So this is something, very unique and new idea, where you have a machine which can build itself and make a car out of it as per your requirement. Customized car, right? So those are some of the concept which are nowadays under development for this 3D printing application. As I have mentioned already, drones are pretty much, some of the drones you see over here are all parts of it are made out of 3D printer, right? And these are working examples. So it's not like they are under development; they are already tested and working very well on the field, right? Fashion. So nowadays we see different fashions, particularly in clothing of people. So here are something or some accessories that can be added to clothing. Besides that, the movies which we see, right, where we see sometimes monster or some person with some artificial kind of shape inside their hand, we can do it by this thing. Maybe uh, in lot of area where aesthetic complexity of the shape is required, 3D printer is very useful. Designing your own clothes, right? So there are devices, right? So people are envisioning that one day uh, the printer will be at home which can print your own clothes as per your design and color, right? So you can choose the type of cloth you want, and it will provide it by that. So those kind of developments are going on using 3D printer technology, right? Again, footwear can also be 3D printed, right? There are some already available in the market, right? So here is an example where an Irish model has wear 3D printed shoes, and because sometimes what happens, you don't get right size footwear, and this is very comfortable and provide good aesthetic. So food we have already seen. So there you can see that there is a sweet which has been made by 3D printers, right? Chocolates or sweets which are made by 3D printers. So there are so many applications where we can use 3D printing technology. I can show you one more application, right? So this application is for space, right? When human can get to the space, uh, or maybe to the moon, how he can use 3D printer to survive. So we can see how we can survive in space, or we can have a habitat or a house in space using 3D printing technology.
Planet Earth is protected by the atmosphere, the layer of air and gas that surrounds it. The atmosphere shields the Earth from solar radiation, keeps the temperature balanced, and protects us from meteoroids. On the Moon's south pole, you can see almost perpetual sunlight on the horizon. This is the site of our lunar base. Conditions on the Moon are very different from those on Earth. Because the Moon has no atmosphere, there is no protection from solar radiation. There are extreme temperature fluctuations, and there is no protection from gamma radiation, and no protection from meteoroids. The lunar lander has detached from the rocket launch and is on a course to Shackleton's crater, the Moon's south pole. Inside the lander is a cylinder which contains an inflatable dome and 2 robot 3D printers. After the cylinder containing the habitation capsule has been unloaded, a dome is inflated from one end. This provides the support structure for construction, a little like scaffolding is used to build on Earth. The lunar habitation is built by a robot-operated 3D printer. At one end, it has a scoop to collect the regolith. In the centre are the containers for the printing material. At the other end, there is a robotic arm with a printing head. The robot collects regolith from the Moon's surface. Layers of this moon dust are built up over the dome to create the protective shell. This process takes about 3 Earth months. The shell is made up of a hollow, closed cellular structure. Under a microscope, it would look very similar to the close-up of a bird's bone. Like a bone, it is light and incredibly strong at the same time. When the lunar base is complete, it can house 4 people. Inside the dome, they are protected from meteorites, gamma radiation, and high temperature fluctuations. The original capsule functions as an airlock and technical support module. The skylights draw daylight into the living and workspaces, which are sheltered within a pressurized enclosure. This method is a pioneering advance in space-age construction. At Foster & Partners, we're used to designing for some of the world's most extreme climates. We often use materials found locally to create sustainable buildings on Earth. While the Moon is an exciting new territory for architecture, the value of this logic endures.
So this was kind of one more application for 3D printer. Now we'll go to briefly how it actually works. We'll see some technical things. First, we'll start with some terminologies related to it, and then we'll go through briefly, and then we'll discuss question answers. So yes, so there are some terminologies which may help you to learn about it. So refers to technology that create objects through sequential layering. So additive manufacturing, as we know, this is additive manufacturing. Uh, it creates objects through sequential layering, right? So basically, layers are being made in regular sequence to ensure that material is added, and that's how it is made. Rapid prototyping. So some techniques are used to quickly fabricate a scale model of physical part using CAD data, right? So the data which is provided by computer software, are used for prototyping of that particular uh, device, right? Subtractive process. So removal of material by methods such as cutting or drilling. So in subtractive process, we cut or drill material to make desired shape of the component, right? For example, if we want to create a shaft, we get a rod and then remove material from it and get its desired shape. While in here, in this technology, we are adding material. And stereolithography, again, system for generating 3D objects by creating cross-sectional patterns. So if you can recall, we had discussed that. So it was started from here, but then ultimately we have transferred to editing adding layers, right? So these are some of the methods or terminologies which we may use, which needs to be understood. Let's go to the next slide. So here we can see in subtractive manufacturing, things are removed out of square. You are making a round shape. While in additive, layer by layer, things are added, right? So this makes you understand additive manufacturing. Rapid prototyping is like, putting layers at one go, right? So this is an example of this same. It has particular scanning direction, and in vertical and cross sectional axis it puts layer. Printing, so machine reads basically the file which is kind of imported from computer software, and then that imported file has been read, and as per the requirement of that component, the 3D printer moves its parts and make a component out of it, right? There are different technologies which we may see. Basically, we may refer to the list. I mean, it takes a long time to go into detail of each technology, but we'll see what are the technologies. So additive processes are basically of five different types. Each type has, so first is extrusion deposition, right? So in that, first the uh, material is extruded and deposited on that particular stand to make layers, and granule materials binding. So in the second method, granules are binded to add material, right? And there are some other processes which requires longer discussion. uh, Maybe we can discuss it on some later opportunity. So I guess we are about to finish the session. So are there any questions?
Yeah, thank you, Akash sir. I would request participants to put your queries. Is there any query from participants, from university faculties?
Madam, Kamakshi Adhyaru, just wanted to know whether the students who have opted for biology, physics, and chemistry can obtain this 3D printing course.
So let me answer that. 3D printer is taught in detail in mechanical engineering, but for other background students, we do have two 3D printers at the university. So by using 3D printers, other people from other stream or background can use them for their particular applications. And right now, people from the science background are also using it. So we just make them learn how to use it, and then they will do it by themselves. But to make a 3D printer, you need to take some extensive courses. But just to use it, you don't need a very fundamental knowledge about it.
Okay, thank you, sir.
Sir, there is one more question about the granular material binding process from Jyoti Grewal. If you can just give a brief of it.
Sure, madam. So granule means uh, small pieces of material. So the in some application, instead of having material in melted situation, the material is mixed with granule particles and binding material, right? And those material are mixed, and then at the time of deposition, they are heated a little bit, and then they are you have to do sintering is another process to make them uh, more sturdy, right? Particularly those kind of things are usually used in construction. As we have seen 3D printer of house, that is classic example of granule material binding. Does that answer your question? Okay, great.
I would request all the participants to kindly go to the chat section and please fill the feedback form. Uh, so there is a query from Mafatlal
Right.
sir. Yeah.
So 3D modeling software, usually SolidWorks is popular right now, and as a part of mechanical engineering curriculum, we teach it, which is kind of USP for us, because in most of the universities they don't teach it, and students have to go outside for some classes, computer classes, to learn it. But here at GSFC University, we teach it as a part of curriculum, and if you learn one software, then other softwares are very similar. So but SolidWorks is quite popular, and we teach here at GSFC University to students, and students are also giving an international exam after their internship in the fifth semester for SolidWorks. Hope that answer your question.
So there is a query from Mr. Chirag Joshi pertaining to the material which we use for the lung manufacturing.
Okay, so in lung manufacturing, so there are some cells which are produced artificially, right? So there are two types of organ manufactured. One type is, for just for sake of getting things done. For example, 3D printed organs which are replaced by you know by some material, for example bone. Then bone doesn't need any particular material. uh, Again, for example, if you just want to pump something, then you just need a gel. So there are some organs which are just created by gel, not human cells. But there are some human organs, particularly the ear, which we have seen, they are developed by human cells. And if you need more information, I can provide it, right? But mostly cells are used to create it, and it will be used for utilizing waste clothes from factories to achieve sustainable fashion. Yes, it can be used to answer RV's question. Hope Chirag's question is answered. But sir, is there any certified material which government has approved? No, these things are under research work, and no material has been approved by government yet, right? Uh, they there, uh, but soon, you know, you will see some of the transplant which are made by artificial material, right? Usually these kind of approval are given by medical societies rather than government. So in USA usually FDA does it, and in India ICMR does it, but uh, they are currently under development stage. Hope that answer your question.
Yeah, one more question from Afatlal sir regarding, the application of our the 3D printer which is available at our university. Its
So
compatibility basically.
right, so in our universities, two 3D printers are available. One is in the design lab in SOT, and one is in guitar lab in SOS. Uh, Both are quite good, right? And which type of scaffolds? So again, our 3D printers are for primary product development. So they can use two materials. Uh, and we have one type material only, right? They are of different color, but material type is same. But if you have some other applications in your mind, then you can bring your own material and do it, right? We have around 10 kg of scrollers with us to do 3D printing of equipments.
Sir, actually, I would like to know about what type of scaffold has been utilized in both of the 3D printers. For example, some of the 3D printers which is utilized generally plastic-based scaffold or some silicon-based scaffold. So, just to create prototype of any machine or any organ or anything. But I would like to have some application in biological science or environmental science. So, if you can provide some insight or light on the what our 3D printers are compatible with which type of scaffold. We can use any scaffold which is available in the market, or that 3D printers is designated for specific type of scaffold. It is not compatible with other scaffold. And also, I would like to know about the programming. So whether we have to utilize expertise of any software engineer, or it can do automatic programming. So thank you, sir.
Okay. Okay, so let me again, mention what I had mentioned previously. We have very primary kind of model manufacturing at our university currently. So the 3D printers which we have uses plastic material, right? Uh, and it is capable of using plastic material as of now. Uh, they are compatible with it. They have a different temperature ranges, so it requires different temperature ranges, and some have capability to use or to be able are capable of using different density of plastic material. But besides plastic material, I don't think any material can be used in our 3D printers. uh, to answer your second question, we don't need any programming uh, knowledge to use it. You just need to understand how to make a 3D drawing. If you have 3D drawing, by knowing machine 3D printer and its primary software which is given by the equipment seller itself, which is kind of specific software to that material. If you can use it, primarily you can. So you don't need programming to do 3D printing. Hope that answer your question.
Yes, sir. Thank you very much for a detailed explanation.
Okay, thank you, sir.
Yes, sir,
Let
there
me
is
get.
one more question from Harsh Rajput. The printing parameters. Which printing parameter basically have the greatest influence on the compressive strength of FDM 3D printed parts?
So there are different parameters which affect strength of the 3D printer parts. One parameter is definitely material, right? The material which we use, its own strength will have impact on the strength of the equipment you are manufacturing. Then the method which you follow. So there are different types of method which has been followed, and as per that your density of your component will evolve, right? So for example, if you want to make things hollow, then you have to follow different method, right? If you want to make things solid, then you have to follow different method. Then there are different precision points which you can follow. So if you want to strengthen something, if you want to provide more strength, it will use more material and it will take lot more time to print it, right? So the main thing of, or main function of 3D printer operator is to optimize it, right? To minimize printing time, because it takes quite a long time to print something, right? So to optimize or minimize the time of printing, as well as minimize the material consumption, and get as much strength as possible, or the required strength for the application for that particular component. Hope that answer your question.
Is there any other question? I would again request all the participants to kindly fill the feedback form. We would be having the session on robotics tomorrow. So I would request all the participants to join us tomorrow as well. Yeah. Any other questions from the participants? Yeah, so Akash sir, certainly like this 3D printer comes out to be a revolutionary invention, especially in the medical, automobile, and the space. That would certainly be exciting to use it soon for the personal use. If we can use it for designing our clothes, preparing food, so that would really be great. But at the same time, economical viability is also plays its crucial role, so as to use it. So maybe have an idea of its cost estimation as compared to the conventional method. This is something which I just wanted to know.
Okay, great. So it is very cost effective when we want customize equipments for limited quantity. For example, if you want to manufacture some component for, let's say, quantity of 5 or 10, it's hard to convince a manufacturer to give it to you, right? And if they give it, because they have to make a mold and other things to get that particular design out of it, so it is very expensive. But if we use this 3D printer, it becomes very cost effective. Again, in terms of organ, because it is hard to get organ donors, it is easy to 3D print them, and it will be more cost effective. And 3D printing is a developing industry, and it is evolving day by day, and costs are getting minimized and getting more effective. Hope that answer your question.
Yes, sir. Thank you.
Okay, thanks.
Is there any input or question from participants or faculty member of our university? All right, so shall we conclude here, Akash sir?
Yes, ma'am.
Okay, so please, again, I would request everybody to please don't forget to give your feedback. It is valuable to us, and join us tomorrow at the same time for the next session that is going to be held for the robotics. Thank you, Akash sir, for this informative session. And thank you to all the participants. Without you, it would have been definitely not possible. Thank you, Santosh sir, for initiating this, and thank you, Saurabh sir, for being here. Thank you, Nishish sir, for always being there and support. Thank you, everybody. Thank you, Mafatlal sir, and all other participants for putting your query and making this session interesting and engaging. Thank you to everybody. Thank you once again.
Thank you, madam. Thank you, everyone.
complete है sir.